Hi class, welcome back. We're going to do systems of equations, so let's get started. So we're going to do these 7 things, so let's do it. Let's solve for both x and y in these 2 equations. How do we do that? Well, it's basically by elimination. I can multiply this one times 2, and that goes to 4x plus 2y is equal to 20. And this one, I do nothing to. 4x minus 2y is equal to 12. All right. So now I add those up. I get 8x is equal to, these eliminate. 2y minus 2y is 0. So I just get this is equal to 32. Dividing by 8, x is equal to 4. Okay, that's the solution for x. Now we need y. Take either equation and substitute x is equal to 4 into it. So this one's right here. I'll use this one. 4 times 4 minus 2y is equal to 12. 16 minus 2y is equal to 12. Subtract 16 from both sides. Minus 2y is equal to a minus 4. And divide by a negative 2. Y is equal to minus 4 over minus 2. The negatives cancel, and we have y is equal to 2. There's our solution. If we check those, we can plug them into these equations. 2 times 4 is 8, plus 2 is 10. It works. 4 times 4 is 16, minus 4 is equal to 12. They work. Now we can also solve this by graphing, and I'll show you basically what this solution set means. We have x comma y. This point, our solution point is the point 4 comma 2. Let's graph this line. Let's call it L1. We let y is equal to 0. We get 2x is equal to 10, and x is equal to 5. So we have the point 5 comma 0, which is plotted right here. All right. We let x be equal to 0. And so we have just y is equal to 10. So we have this point, 0 comma 10. And we can plot those 2 points. We had that point and this point. And now we can graph that line. Okay, it's close to that. For L2, if we let y be equal to 0, we got 4x is equal to 12, and x is equal to 12 divided by 4 is 3. And if we let x be equal to 0, we get minus 2y is equal to 12, because you plug in 0 for x and 4 times 0 is 0. And we get y is equal to divided by minus 2, minus 6. So we have the points 0, minus 6, and the point 3 comma 0 from here. So we can plot those. 3 comma 0 is right here. And minus 6 comma 0 is right here. And that's roughly this graph. So roughly our solution is right here. And that's roughly 4 comma 2. We call this is L1. And this is L2. And all the solutions for L2 are on this line. All the solutions for L1 is on this line, and the intersection solves them both. Okay, let's do another one. This time, our coefficient, we don't have any ones in here. So what we have to do to solve this one is we just have to get one of them to eliminate. If I multiply this one by 5 and this one by 2, since there's a negative there, I'll eliminate the y's, we'll get, you'll see, 5x minus 10y is equal to minus 15. So multiplying by 2, we get 8x plus 10y is equal to 2 times 19 is 38. Now, if I add these up, my y's eliminate. I get 23x is equal to, let's see, that's going to be equal to 23. So x is equal to 1. Okay, now how did that work? I'll just multiply this times this. I'll just multiply this one times this one and this one times this one, and they're going to eliminate. Now we have a solution for x. So now we need y as well. So I'll plug it into either equation. This one's right here, so I'll plug it in here. 4 times 1 plus 5y is equal to 19. So that's just 4. Subtracting the 4, 5y is equal to 15. Dividing by 5, y is equal to 3. So there's our solution. Always good to check. So I'm going to write the check here. If I plug these in, we get 3 times 1 minus 2 times 3. That's equal to 3 minus 6, which is minus 3. And that's this answer right here, so yes. And then we have 4 times 1 plus 5 times 3, which is equal to 4 plus 15, which is 19. And we know we got our answer. If we have parallel lines, let's graph these real quick. X is equal to 0, so y is equal to minus y is 8, so y is equal to minus 8. So we have this one. And y is equal to 0. We get, again, we're graphing this line. If y is equal to 0, we have 2x is equal to 8, and x is equal to 4. So 4, 0. There's our two intercepts. And graphing that line, it's approximately that. Doing this one, x is equal to 0. We have minus 2y is equal to 12. And y is equal to minus 6. Okay, we have this point. Y is equal to 0. And we have 4x is equal to 12. And x is equal to 3. Okay, graphing that line. We basically have this. And they're parallel lines. They're not going to be any solution. They never cross. What happens when we try to solve this? Let's erase this here. Okay. Well, if we try to solve this, I can multiply this one times a negative 2. And I'll get, this is going to be minus 4x plus 2y is equal to a negative 16. This one I don't do anything to. 4x minus 2y is equal to 12. When I add those up, both these eliminate. Minus 4x plus 4x is 0, plus 0 is equal to a minus 4. I get a nonsense answer. 0 is equal to minus 4. Nonsense. Therefore, no solution. No solution. One more situation is when we basically have the same line. Now, let's solve these first. If I multiply this one by 2, we get 6x multiplied by minus 2. So we can get the y's to eliminate. We have minus 6x, well, the x's, plus 2y is equal to a minus 12. And this is 6x. 6x minus 2y is equal to 12. And if I add those up, x's eliminate, y's eliminate. 0 plus 0 is equal to, these eliminate too, 0. 0 is equal to 0. True statement. True statement. So we have infinite solutions. What happened? If this is L1 and this is L2, let's plot those. L1, if we let x be equal to 0, minus y is equal to 6, and y is equal to minus 6. And that's right here. If we let y be equal to 0, we have 3x is equal to 6, and x is equal to 2. Okay, we have that point. Now if we plot that, okay, we have this line. Now for L2, if I let x be equal to 0, then minus y is equal to 12, and yet y is equal to minus 6. Same point right here. Now if we let y be equal to 0, I have 6x is equal to 12, and x is equal to 2. Same point, so same line. So all these points work for both of those equations because they're the same line. So we have an infinite number of solutions. Part 5 is an application. Say you invested $20,000 in 2 accounts, stocks and bonds. The stock account turned out that it earned 7%, while the bond earned 2% in this particular year. You had a total of this amount that you earned. How much was invested in each? Okay. Let x be equal to the amount in stocks. And y be equal to the amount in bonds. Okay. So we have x plus y is equal to $20,000 because that's everything I invested. But we also have 0.07 times x plus 0.02 times y, 7% of the amount that we get. So this is the amount of interest, is equal to 1150. Okay. So how do we solve that? Well, same thing. The key was setting up those equations. Right, 7% of the amount in x is what I earned in stocks, and this is what I earned in bonds. Added up, we get that. All right, so we need to do elimination or even substitution. All right, substitution is good. If we solve for, say, x here, x is equal to 20,000 minus y. We substitute that in for x. And we get 0.07 times 20,000 minus y plus 0.02y is equal to 1150. We distribute, and here we have 1400 minus 0.07y plus 0.02y is equal to, combining these, let's subtract that one over there and subtract this one over here. Get rid of the negative sign for the y's then. That's equal to and so then y is equal to divided by, and that's equal to it's equal to 5,000. So $5,000 was in bonds. So therefore we can use this equation, and we know that x must then be equal to 15,000. So we had 15,000 in stocks and 5,000 in bonds. Okay, now the new stuff. How can we solve a 3x3? And what you do is you have to eliminate one of the variables and bring us down to a 2x2, and then we can solve that one. So let me show you what I mean. If I take these two equations and just add them up, the z's cancel. So let's do that. I get 3x, because I'm adding this one and this one, plus 3y, because I'm adding that one and that one. Those eliminate, is equal to 9. Now I can do the same thing, but with a different set of equations. If I take this equation and this equation, add them up, the z's eliminate. So let's do that. This one plus this one is 5x. That one plus that one is a minus y. That one and that one, the z's eliminate, and this one plus this one is a 3. Okay. So the main idea is that we took a 3x3 and brought it down to a 2x2. Okay. Now this one, we can solve the way we did already. So if I multiply this one by 3, we get, this one just comes over, 3x plus 3y is equal to 9. Again, I multiply each term. 15x minus 3y, see I'm eliminating the y's, is equal to 9. We add them up. 18x, the y's eliminate, is equal to 18. So we get x is equal to 1. All right. Well, we have to get y and z as well. So we can use either one of these equations to get y now. We'll just use this one right here. Okay. Plug it in 1 for x. 5 times 1 minus y is equal to 3. Subtracting 5, we get minus y is equal to minus 2, or y is equal to 2. But we also have to solve a z. So we take any of these equations and plug these numbers in for here. We'll just use this one since it's right here. 3 times 1 minus 2 times 2 plus z is equal to 2. That's 3 minus 4. That's minus 1 plus z is equal to 2. So add 1, z is equal to 3. And there's our solution right here. Z is equal to 3. So we solve for x and y and z. It's always good to check. Plug them in. We get 2 times 1. We get 2 plus 2 for y minus 3 for z. And that's equal to 1. Check so far. This equation, we plug in 1 for x, we get 1, plus 2 for y, we get 4, plus 3 for z. Okay, it's 5 plus 3 is 8. So far, so good. Let's do this last one. We have 3, plugging in 1 for x, minus 4, plus 3. And that's 6 minus 4, or 2. And we got our solution. Okay, another example for a 3 by 3. We do the same thing, but let's pick a different variable to eliminate. And let's pick the y's to eliminate. If I add these two up, the y's will eliminate. So adding those two up, 3x, right? That one plus that one. These go away. And we have plus 4z is equal to adding these two is 18. Right? We can add two equations together. Now we have to eliminate the same variable and use different equations. So let's use this one and this one. But they won't eliminate immediately, so same trick. We just multiply this one times 2. Okay, if I multiply that one by 2, I can just write that down here. 2x plus 2y plus 2z is equal to 8. Now I can add those up, and I get, I'll just write it over here, 5x. Those eliminate, and we get 6z is equal to, adding these up, 28. Okay, so we reduced a 3 by 3 to a 2 by 2, and we know how to solve this. So let's eliminate the x's. I'll multiply this one times a minus 5, and this one times a 3. Now, then they'll match up. So we'll get minus 15x minus 20z is equal to a 90, or minus 90. Multiplying this one by 3, 15x, we see those will eliminate, plus 18z is equal to, and 3 times 28 is 60, 84. And now if we just add these up, those go to 0, 0, eliminate it, minus 2z is equal to a minus 6, and z is equal to 3. Okay, we got our first variable. Let's get a second variable. Use this equation. 5x plus 6 times 3 is 18 is equal to 28. 5x is equal to 10. And x is equal to 2. Very good. Now we just solve for y. We can even use this equation or this equation. Let's use L2. Really a plain 2, but L2. So we get 2 plus y plus z, which is 3, is equal to 4, right? We're using this one, 4. So y plus 5 is equal to 4. Subtracting y is equal to minus 1. Okay, so we got our solutions. It's good to check them. Let's first check L2. If we add them all up, do we get 4? Let's see, this one plus this one, that's 5 minus 1 is 4. Yep, so this one worked. Let's check this one. 2 times 2 minus a negative 1. And this one is plus 3 times 3. That's equal to 4 plus 1 plus 9. That's equal to 14. Yep, that one worked. This last one, L3. Let's see, we got 3 times x, which is 2, minus 2 times a minus 1, y, and plus 4 times z is 3. What's that one? We got 6 plus 2 plus 12. That's equal to 14 plus we got 20. And that one worked too. So we are done. Well, I hope you found that useful and helpful, and I hope you enjoyed your learning. Cheers.